Hi, my name is Corey Taylor, CNT6519. I'm going to talk to you about device security, specifically focused on Wi-Fi attacks and defenses. My schedule for this is pretty aggressive, but I want to go through it. Start with that hardware, talking about how the device itself can be its own vulnerability. Talking about firmware, which is that middle ground between hardware and software. Software itself, external devices, and how that plays a role, and then going into Wi-Fi specifically. Defenses for defending yourself as a user, and then how that plays a role in the commercial world. So, knowledge is power. To be secure, you need to know a full taxonomy or list of all the different vulnerabilities that exist out there and how you can defend yourself from them. Typically, the biggest risk in a company is you as the user, so you want to eliminate that as the weakest link and leave it to the other parts that you're not responsible for. Like hardware, firmware, software, and those external devices. And a lot of those risks are, for instance, losing your intellectual property. So say you invented something, some other company can steal it, your stolen identity, and much more. That's just the tip of the iceberg. So why is hardware important? Well, despite the media's attention on software vulnerabilities and data collection and all this, there is a lot of flaws in hardware. A lot of the hardware we have right now is outsourced to other countries, made in China, Taiwan, etc. And the reason for that is cost and time. So this inevitable dependence on third parties has brought a lot of vulnerable weakest link points that we need to account for. And there are a lot of concerns with that because there have been attacks detected in the past. A lot of papers have put together a lot of work into putting together a full taxonomy or a list of all the theoretical and known points of attacks that have been made and could be made on hardware, including the triggers, the payloads or the effects, locations, and the different levels to which and the degrees to which those hardware Trojans can play a role. So where are the most common places that Trojans are placed? Well, from the design or the fabrication side, you have the HDL source code of the integrated circuit or the IC, the circuit diagram itself, so whenever it goes to that phase, or at the production side whenever it goes to the foundry or the fabrication plant. These are different places that malicious intent can be recognized or implemented. So what is a hardware Trojan? What does it look like? The basic form of it can be shown right here in the bottom right. You have your message being sent through and it's encrypted, or was. Now I as an attacker put a mux or a switch with my little flicker per se, and then the output. So say you're sending an encrypted message to a friend, I can then flip this mux or the switch saying, hey, just send me the clear text. Now I know exactly what you said without it being encrypted because of this one little switch in there. Where can this be stored? Processor, memory, IO, clock grid, power supplies, a lot of places can be placed. So keeping something like this under control is very important because it's very hard to find something, especially if it can be as little as that. So what are some of the triggers? Some of them are just always on. Straight out of the fabrication plant, you have a trigger on, or you have your payload already activated. Some of them are triggered. One is like a time bomb, so every a certain amount of seconds or a certain amount of times you press the space bar. Other ones are a physical condition, so say you're running a video game, processor gets really hot, now it's activated. Other ones are user input, so I type in an obscure string of text or I push a button that's not really common like F12. Some of the payloads are changing functionality. Say if I have a system that always looks for the word Moscow, it'll change it to Boston. Say I want to launch a missile to Moscow, now it's going to Boston. Bad news. Downgraded performance or denial of service. This is typical of companies who say they want you to buy the next year's version of the printer. All of a sudden after a year your printer stops working when you need to buy the next one. Leakage of information. So say, like I mentioned earlier, they can steal your non-encrypted information through broadband over power line or a flicking of a light. A lot of different ways to leak that information out. Most common defense, there are a ton, but the one I want to talk about is the most common I've seen, and that's called IC camouflaging or integrated circuit camouflaging. On the top image on the right here, this is a NAND gate. And then if you use different types of metals under an electron microscope, it will look the exact same thing to an attacker. However, it's extremely different. So instead of a NAND gate here, now I just have an always on or an always off. So someone trying to replicate this chip will have something that doesn't work properly or just doesn't work at all. Another way is to disguise it. So say this is the circuit itself. Instead of making it simple and clear to read, I just flood it full of stuff. So now anyone trying to look at the circuit will just be confused and it'll take forever to figure out. Now you've gone over a little bit of hardware. We're now going to look at firmware, which is that middle ground between hardware and software, and then talk about software a little bit. So what is firmware? Firmware is defined as the combination of hardware and data that reside on as read-only software that is on the device. Ugh, say that 3 times fast. So why is it important? It's important because most consumer products, including automobiles, have firmware installed on them. And I, to this day, have never seen a firmware update for my TV. It's not cost effective, and it's very hard for someone who's not tech savvy to go through and update their firmware, especially to something that's really hard to get to, like a television. So if I wanted to go through and hack your firmware for your TV and have you only see a hacked video stream, I could do that. And to prevent that, it's very difficult. So what is one of the vulnerabilities that exist in that? So like I just mentioned just a second ago, you have this firmware. Well, burnt in your firmware is a recognition of HIDs. Well, what are HIDs? HIDs are human interface devices. A human interface device, when it's sent, will show you your vendor ID and your product ID. So say vendor is Dell and the product is this specific type of keyboard. So say I want to whitelist. I'm only going to allow this type of keyboard. I don't want anyone's USB drive on my computer. That's fine. But if you do that, I know exactly what kind of keyboard you have. So I want to tell my USB, hey, tell that computer that you're a Dell keyboard. So now it's a Dell keyboard. What's the problem with being a Dell keyboard? No time have I ever seen a computer say, hey, you have 2 keyboards plugged in. What's going on? I mean, this is a bad deal, right? No one's going to say that. They're just going to say, hey, installing your driver, keyboard's installed. So I plug in a USB drive that's full of malicious intent. It's now your keyboard. Everything's run through hotkeys. It can open up command prompt. It can run a secure shell, do all kinds of crazy things. So what's an example of this? Well, you have this background script running called LSAS, which has all your credentials and security information. That's what tells your computer, hey, this is Corey logged in the computer, or this is the admin logged in the computer. They can do this because they entered the right username and password. Well, now you have tools like Mimikatz who can interpret that data or that file and say, oh, now I know this person's username and password from this process to run the background. And then you have this thing called PromptDump version 6.0, which is provided by Microsoft on their website, so you can easily download it. Well, that's cool, but you need physical access, and this probably takes forever. Not really. You could probably do it in about 5 minutes, which includes the 30 seconds for the USB drive to download the file, Mimikatz to process it, which takes about 3 seconds, and then to write all the files to your USB drive and save it. Okay, that's fine. So you ran this for 5 minutes, but I'm back in my seat now. There's nothing you can do. By the way, here's the script right here if you wanted to do it. So it's not that too hard to find. Even if you really want to find it, you don't have to look at my presentation, you just Google it. So now I have your username and password. What now? Well, no one I know sits there every day and coming into work and looking down like, oh, what's in the back of my computer? Oh, it's a USB drive. And even if you do, there's probably a few days where you don't do that. So if I have this script running, it's key logged or grabbed your username and password, and then it's ran this script, this shell right here. So now I have root access to your system. So it's like, wait a second. Can I just check my log files and say, hey, this process is running, I don't want it to run? Yeah, you could, but then if I add this little few lines right here, it'll delete that log file as if I've never even been there. So then I could just plug the USB drive in the back of your computer, go home, and then now I have root access to your computer. Rubber Ducky USB is the easiest commercial over-the-shelf device to do this. There's been other ones called like the Glitch, a little bit more expensive but more efficient, and there's tons of other tools as well. You just need to Google them. So we've seen it's super easy, firmware attacks, hardware attacks, and then even external devices attacks. So let's assume all that's gone. You're completely safe from that. There are still features on your system, like say your NIC, your network interface card, that allow you to connect to things like the internet through Wi-Fi. That itself is a risk. So we're going to look at that. Wi-Fi, to give you some background, stood for Wireless Fidelity, created by the Wi-Fi Alliance. Its name stuck as Wi-Fi because it's a lot easier than saying IEEE 802.11, because no one says, hey, do you got that IEEE 802.11 running? Can I get access to it? Everyone says, do you have Wi-Fi? It works on the ISM band, about 900 megahertz as the point of interest. and was originally intended for industrial use. So for instance, the original use of this was in the Netherlands with cash registers, and now we just took it and used it on everything. And there are many benefits to it, which is why it's caught on. It's really fast, it's cheap to set up, it's used anywhere. I can go to Japan if I want and hook to Wi-Fi. I don't have to buy another hardware piece or install a driver. It's just automatically there. It does by default for the most part support encryption, and it does operate in an unlicensed spectrum, so I don't have to pay for every time you use Wi-Fi. And this little graph right here will show the evolution of the different ones. So right now I think 802.11ac is the current standard, so if you want to find out more details, feel free to Google 802.11ac. Wi-Fi does operate within that spectrum on 11 different channels, actually 14, but in the US of A we're only allowed 11. The rest of the world is about 13 channels, and then Japan is unique because they're allowed 14 channels because they're special, I guess. And because we don't want the overlapping of channels, we typically use channels 1, 6, and 11 as shown here in the bluish humps. So to find out what channel you are in, you can run the script right here. It's also easy to change it. So say I want to illegally operate in the 14th spectrum and send data to my friends that way, I can do so by running the script here. By the way, as a side note, these scripts and all other scripts mentioned in this presentation are done in Kali Linux, and I do that because it's hard to show both Linux and Mac and Windows, so just stuck to something that's a little more common to the tech crowd. So what is this detail about my NIC or my network card, and how does that play a role in how they communicate? Well, everything has a MAC address or a media access control address, and what that says is that's your ID is saying, hey, I am this type of HP laptop or that Asus, laptop or this Samsung phone. To check out what your particular MAC address is, you can run this script right here. And you can change it too. So say for instance, a lot of airports will only allow you a free amount of Wi-Fi for a certain amount of time per MAC address. So if you want to get free Wi-Fi forever, every 15 minutes you can set up to where you can change your MAC address, and now you have free Wi-Fi again. And you can just run this little command right there. So as I mentioned earlier, each network interface card has 6 modes of Wi-Fi. What are the modes? First one is master, so that's the base station, the one that's sending you the data. Then you have manage, or the infrastructure mode. That's typically what me and you have as the client, which is where we receive the data. To see that, you can run the script right here. The other one is ad hoc mode, which is where you can run the script right here at the bottom. And if me, you, and a bunch of other people ran that script, we could all be in this little micro ad hoc network talking to each other. Other one is a mesh network. So an example of that is right here in the bottom right, where we're in a city and we want to create a mesh of nodes talking to each other. And we can get in that a little bit later too with WiMAX, and we'll talk about where that's leading. The 5th mode is repeater mode. So say I'm over here and I want to send something 2 miles away. I can have little nodes all along the way to send something 6 miles long to you, and that's called a Wi-Fi repeater or extender mode. Next one is monitor mode, and this is where all the interesting fun stuff happens. This is where you can see all the packets sending throughout the air and what's going on. So if I want to change myself to that mode, I can install a few tools like T-Shark and AmmonNG, which come default with Kali Linux, and run this script right here and switch myself to monitor mode. Now I can listen to everything. Well, how do I listen to everything? You download a tool called Wireshark, unless it's already installed, and then you can see the traffic being sent to and from. And you can find out by doing that script right there. Before I continue, I do want to mention a little bit about transmission power. We are in the US of A limited to a certain amount of dBm or milliwatts for transmitting our Wi-Fi, and that limit is given here, 500 or 20 dBm. One country, for instance, has a much higher limit, and that is Bolivia. So if you want to be a little bit illegal and send that, you can tell your computer, hey, I'm in Bolivia right now, by running this script, and now you can transmit up to 30 dBm. Don't do that. And if you didn't want to do that, there are a lot of DIY and commercial ways to extend the range and boost your power. One of the examples is pictured right here. So I did want to spend some time talking about Wi-Fi states and frames. So what's in a frame and why is it important? Well, a frame has your source and destination, the type of data it is, like TCP or UDP, like if you're sending up or down or whatever, the payload, like the point, and your frame check. So say like an MD5 checksum or CIRC. And then you have your types of frames, which are like control frames, which you can see right here, where one node says, hey, can I communicate? This guy says, hey, can we communicate? Nope. Okay. Hey, can I communicate? Yeah, you guys can communicate. All right, I want to send the data right now. You done? Yep, we're both done. So that's what the control frame does. You have your data, which is the actual data being sent. So if I'm sending you, say, a picture. And then there are management frames like beacons, probes, authentication, association. And we'll get that in a little bit. The most interesting one is beacon frames. Why? Why is that important? Well, if you ever go to someone's house and you turn on your Wi-Fi on your phone, your computer, and you say, hey, this is Jeff's Wi-Fi, or this is Corey's Wi-Fi zone, or whatever it is, you can see that. It's broadcast about every 10 seconds. So if you open your computer, you don't see it right away. Wait about 10 seconds, you'll see a full list of Wi-Fi beacons being sent out. You can hide and remove these if you really want to. And what is the problem here? Why is that so interesting, and what vulnerabilities exist there? Well, I can do something called a Wi-Fi beacon flood, to where I can write a script that'll send out 1,000 beacons. So if you're looking for, oh, I want to connect to UCF's guest network, and all of a sudden you see 1,000 beacons show up, that's because someone just ran this attack, and it's going to take you forever to even access one, or your NIC card can be overwhelmed and just crash, and you can't get Wi-Fi at all. So it's something to be careful with. You can analyze each of these frames as beacons with something like Wireshark or AirmonNG, and if you want to use AirmonNG, you can run this command right here. It's also something you can do with beacons where you can become the man in the middle. What is the man in the middle? That's like you hand me a message, I look at it, and I hand it to someone else. There are problems with that where I can either add the information, delete information, or modify information, or simply just record it and keep that information for myself. How do you do that? You shut everyone else down, and you say, you can connect to the internet, but only through me. You can run that command right here if you wanted to do that for whatever reason. But if you did that, now they have to run through you, and they run through you, now you can see everything that they're sending. So pictures, texts, emails, whatever. What are some defenses? Well, one of them is the frequency hopping spread spectrum. So say, remember I talked earlier, there's channels 1, 6, and 11 that we can send data on? Well, there's about 70 different patterns that exist where I can send data chopped all throughout the network. So I don't have to send on just one channel, I'm splitting through all three. One person at DEF CON at 2012, I believe, created this Hello Kitty backpack with 14 different receivers on. So listen to all 14 channels. Remember, there's 14 including Japan. And he listens to all of it and records it. He recorded about a 30-minute session, went home, analyzed that with 70 different patterns, and was able to prove within a few hours that he could decode all the traffic being sent through and find out exactly what data is being sent, getting images, texts, phone calls, everything he wanted. So it is a real vulnerability, and there are ways to defend against it, but just because of the sake of time, I don't have time to cover it right now. So talk to you about WiMAX. Why is WiMAX important? So Wi-Fi has a limited range. I can't set up Wi-Fi in my house and get it at Wi-Fi in Orlando, and I can't get it away in Melbourne. That's about an hour drive, 50 miles plus, and I can't get Wi-Fi. But if I had something called WiMAX set up, I could get it. WiMAX is great, but then again, therein lies a lot of vulnerabilities in as well because of the type of technology it is. WiMAX is set instead of the standard IEEE 802.16, like Wi-Fi is instead of IEEE 802.11. Stands for the Worldwide Interoperability of Microwave Access. Say that 5 times real fast. There are varying degrees of security, so if you want to have straight here to there, or we can have different redundancy of servers and repeaters to where if someone tried to do a denial of service attack or corrupt a server, I have different servers and repeaters to send the data to me. An example of that is the top right here. I see just the standard WiMAX network, and then here's something with redundancies in servers or repeaters. There has been a lot of research into trying to merge Wi-Fi and WiMAX. So say I want 2 WiMAX nodes, and then after this WiMAX node, I want a bunch of different little Wi-Fi nodes to connect to. The current opinion on that is it's not currently stable or robust enough for a true wireless network. And the reason why is because it lacks the mutual authentication needed for replay attacks or protection against spoofing for MACs. So because of that, it hasn't been truly integrated or used globally widespread yet. But if it does, there are a lot of benefits. Aside from the initial upfront investment and cost, in the long run, it is a small minimal cost. It's very simple to set up. It is flexible and scalable, so if I want to move a node, I can. It has a lot of app support, so I can do voice over IP if I want to. I can do billing, so if I'm a utility and I want to bill people locally, I can have e-commerce set up, a bunch of things. Typical of internet, just think local area network. So I've covered a lot, covered the introduction, covered hardware and the complete history and potential for vulnerabilities there, firmware, software, external devices like the little USB drive, USB rubber ducky, Wi-Fi and what's in it. So I'm like overwhelmed, I'm like, all right, there's so many vulnerabilities, I'm paranoid now, what can I do? Great, glad you asked. So here's some things that you can do to defend yourself. The general consensus is you need to be CIA. You need to be confidential, making sure your message is understood only by the person I'm sending it to. You need to have integrity, meaning the message was not altered at all. And it needs to have authenticity and availability, meaning the server, sender, and the receiver, the client, are who they say they are, and the message was delivered as required, as in there's no denial of service or any kind of attack like that. Standard symptoms, like saying, hey, do I know if I'm hacked? As if your download or browsing speed is slow, your connection breaks pretty frequently, your usage bill escalates. So say if on your phone you're billed for your usage, you can check your apps and figure out what's connecting. Like if you have a flashlight app that all of a sudden spent 2 megabytes worth of data, it's not just a flashlight app, it's something different. And unusual log activity, so check your log files if you know how. There was a general report put together for 10 steps to security, and those are changing your default admin username and password. That should be straightforward. Turning on your compatibility protection, like WPA or WEP. If you have WPA2, please do that one. Don't do WEP. You can crack that in about 5 seconds now, I think. Enable your firewalls on both your computer and your router. Extra security matters. Disable auto connect features. If I'm set to auto connect to my home router, and I'm out in the wild, like the airport, and I try to connect to a router somewhere, as soon as I turn my computer on, it's going to try and connect to my home router. If some attacker is out there sitting there listening, he can listen, hey, this guy's trying to connect to me, and then he can become that access point. That's called a karma attack. So Google that if you're more interested on that. Position the router or access point safely. So for instance, if my router is right next to a window, people outside in the street can pick it up. But if I connect it right next to a wall, it'll keep the Wi-Fi pretty much inside the house. So that's really important to consider. Turn your Wi-Fi access point switch off when you're not home. So if you leave for a week, turn it off so people can't run up next to your wall and try to hook up your Wi-Fi. Assign a static IP address to your devices. So if you're dynamically looking for anything, anyone can connect, but you can statically assign only this person or that person connect to my internet. Change your default SSID. Your SSID is like default, Linksys, Corey's Home, UCF Guest. Change it to something unique, special for you. That way someone won't defaultly connect to some unique network. Disable the broadcasting, so that way people can't like just look for it. You have to manually set it up in your computer. I want to connect only to this network. Enable MAC address filtering. Like as I mentioned earlier, every network interface card or NIC has a MAC address. Use that to your advantage. Only whitelist only devices you want to connect to your computer. And this is a very minimal list. You can go way deeper if you really want to, but long story short, it's not a one-time fix. You have to be on top of it, you have to stay up to date, and you have to make sure that your security is still intact and hasn't been compromised in any way over time. So I talked about residential, talked about a lot of vulnerabilities. How does this play a role in commercial world? There is utility hacking. A lot of times for water and electric, there's people who go by and manually on a sheet of paper write down like, oh, this guy used so many kilowatts worth of hours or so many million gallons or whatever. But to make a more cost-effective solution, they've enabled this thing called smart grids, where you have smart meters connected, or even in your house where you have like the Nest thermostat that can sit there and automate the process of turning your air conditioning on and off. That's great, but in itself, because it is a computer, so to speak, it does have its vulnerabilities laid in. There are a lot of benefits, like it does save energy, so if I want to automate turning things on and off, it does reduce on the production costs and on labor costs, so I don't have to pay someone to walk around and read the data, I just have to have someone at home. And it does increase the reliability of the grid, so I can automatically detect when something's going extreme and turn it off from a remote location. It is a huge global market. In 2010, there was $23 billion worth of investments made. Within grants alone, $3.4 billion was done by Washington, $4.9 was done by the private sector. So it is a huge market, and a lot of innovations have been done. And a lot of people want to do it because it is a very green device. And I'm sure a lot of people have heard the word green or sustainable. Walmart, for instance, has the green logo on a lot of things because they're using the reusable bags. Despite the fact that they're not environmentally friendly at all, they try to promote that to try and attract that crowd. So that being all said, right now about 28+% of the market is smart meters. So it's a huge market for vulnerabilities out there. You can divide this little RFT Pro on the right. A lot of people are using that to do what's called a replay attack. So say if my meter is sending out, hey, I'm spending this much energy, I can listen to that on this little device and then modify it and say, I'm actually spending only 2 cents an hour instead of $20 an hour. That's a big security risk. Other threats are in July of 2011, one person was reported bringing their laptop into a sewage plant and dumping 200,000 liters of sewage into the water supply, further just contaminating that system. And then one was in Census, which is a worm that was created to navigate through an electric grid to map out the electric grid. That way they could find out what the best point was to attack, to say if I shut down this node, it'll shut down this entire electric grid in this direction, like a city, for instance, or a county even. Even though it hasn't happened yet, the biggest concern right now is for water plants. Most water plants don't have backup generators. So say if I'm an attacker, I can open up the gates and dump all your stored water from your water towers or whatever. I can shut down your generators, and then now the city doesn't have water for a while. That may not be a big deal for me and you because we can wait on taking a shower, but say if you're a utility plant who needs water for like coolant to keep your stuff from overheating and exploding, that can be a big deal. So we've covered a lot of stuff. I want to spend a little bit of time talking about related works that have to do somewhat with Wi-Fi, and then conclude. So RFIDs, how's that important? Passports, your car keys, your e-pass for your tolls. A lot of things use RF, radio frequencies, and have those IDs applied to it. I can use common devices. They're really cheap to buy, like this yardstick one right there. About $100, I think you can get it on eBay right now, or Amazon. And I can sit there and listen to frequencies. So say if I want to be you and transmit your e-pass ID, I can never have to pay tolls again, and your bill goes way up. Same thing for Bluetooth. Bluetooth has a lot of redundancies and the vulnerabilities in that. For instance, a lot of the passphrases or pins are set default to 0000 or 1234. So if I just sat there and brute forced it, I could get through and log onto your device in no time. The other thing is once I'm logged onto your device, I can grab your call history, contact list, text, a bunch of information, which is very vulnerable. Each of these have a huge amount of history and research done into them, so I don't have the time, but I do encourage you to spend some time on looking to that. YouTube it, Google it, go to IEEE Explore, look at some research. It's really interesting stuff. So in conclusion, knowledge is power. Security is being able to understand the taxonomy of the vulnerabilities and risks. The biggest risk is you, and if you can remove yourself from the equation, that's all the better for not only yourself, company you work for, your family, your friends, everyone. Protection is not a one-time thing. Stay up to date. Keep yourself updated. Know your points of risk, your hardware, firmware, software, knowing that other people can plug devices to your computer at any point in time. Wi-Fi and you are a big security risk in itself. Share what you know, stay up to date, and be safe. All right, thanks guys.